In this video we're going to look at why magnetism passes through iron so well, and it's related to our study of transformers. If we imagine within iron there's lots of little areas called domains, and each of these domains is like a little magnet in itself with a north and south pole. Now if we look, because they're randomly arranged, these domains actually cancel each other out. For each magnet pointing one way there's a magnet pointing the opposite way, so there's no overall magnetisation. This is why the point magnets, when iron becomes magnetic, it's when more of these are pointing one way than they are pointing another way. So if we zoom in, and then if we replace the little arrows with bar magnets, what I'm going to do now, if you imagine I'm bringing the north pole of a magnet from the right hand side of the screen. As I do so, the magnetic field strength increases and all the little domains line up. Eventually all the magnets are pointing the same way, and this is called saturation. At this point the iron is as magnetised as it can possibly get. Now in a transformer we imagine we apply a sinusoidal voltage to the primary coil. So we have this sinusoidal changing current generating a changing magnetic field, and this causes the domains to swap from one side to another. If you look, the maximum magnetisation when saturation occurs is not at the highest and lowest voltages, it's actually when the voltage is changing by the fastest rate, which is around the 0 volt mark. So if you watch, we have minimum magnetisation, maximum, then a minimum, then a maximum again. This is quite an important concept, though it's stretching more into A level, that the magnetisation is proportional to the rate of change. If we have a look at the gradients, we can see that the gradient here at 0 volts is actually steeper than any other place on the curve. So, if we now bring a magnet into a piece of iron, let's look at why this is happening. As the magnetic field increases externally, all little domains line up. Now, normally, if we imagine the iron wasn't there, the magnetic field would spread out through space, and it reduces with distance. So basically, as we get further away, the magnetic field lines get further apart, and the field becomes much weaker, and it becomes weaker very quickly. But if I put my iron bar there, because all the domains are aligned, effectively the magnetic field exits the iron with virtually the same strength as it entered. And this is why iron is so much better at permeating or conducting magnetism. It's more than 1,000 times better than air, depending upon the type of iron and the structure of the iron core in a transformer.